Okay, we're continuing on deep dive into Mastercam 5-axis, curve 5-axis toolpath. This is our second day, but it's our fourth session. We're breaking, we're breaking each day up into multiple videos to keep the recording length relatively manageable. And we just got through talking about collision control strategies and covering more about tool axis control. So lead and lag, side tilt, what are those? Another example of angle increment, and then tool axis control relative to a surface with the ability for projection. All right, we're going to continue on. Let me just jump out of there. Okay, so many of the paths in Mastercam can be stock aware, and you can use that to tell the toolpath where to cut and where not to cut. So do something where it'll be kind of obvious. I don't know that this is a particularly good example to just throw stock on. But one thing we could do, just to see it, translate this just copy this. So we got a path going through here. One of the basic concepts that's kind of universal throughout all of these 5-axis paths is that you've got these three sets of controls that are going to work in combination with each other. You have the cut pattern, you have your tool axis control methods, and you have your collision, or what I like to consider the compensation for the tip control. You've got some kind of linking, and that's generally how do we approach the part and retract from the part at the start and end. How do we move and transition between different cuts that are occurring on the part, whether it's a single chain you're following with curve 5-axis, or whether you're doing curve 5-axis with depth cuts and with multiple stepovers, multi-passes. That all is kind of connected together with these linking moves. So we've talked about cut pattern for curve 5-axis. We've talked about tool axis control. Axis control. We do have this option for limits. So depending on what type of path you're cutting, and it's not going to be kind of as obvious here because we're not doing a whole bunch of motion. We're just doing a square, basically, a rectangle of geometry. But you can turn these on to give you a cone that is centered on the axis. So within that spread of values, you can enter your minimum and your maximum. Now, again, not super applicable to this particular path. We'll look at doing kind of a spiral pattern on the hemisphere in a little bit, because that'll really highlight where this can be useful. For gouge processing, depending on what you're cutting, sometimes, it can be looking way ahead at other vectors or something. You may need to limit your look ahead. And I've had to do this on trimming paths, 5-axis trimming paths. So I would also look at that, Brock, when you were looking at your issue with the projection. You may have to turn down your look ahead to like 10 or 20 moves and see if it could be an infinite look ahead issue that's kind of dropping those sections of the toolpath.
Yeah, I think this one in particular was likely copied and pasted from another location with attachment to other geometry.
Sure.
So probably inherited some links to that surface. And then additionally, I think the combination of the solids, I pasted that picture in there day before yesterday. I think some of the edges were likely on the negative side of the surface. Yeah. I wonder if that might influence it. Have you seen any problems with that before?
Always. Yeah, okay. And that's where, you really, there's a lot of tools for dealing with surfaces in Mastercam, and solids are great, but surfaces give you control. And so whether the starting point is a solid or a surface model, quite often we're using some kind of combination of both solid and surface geometry. And the dream is to be able to just program directly off a 3D solid model and not have to create any extra geometry. I've seen times where that worked successfully, but more often than not, I end up having to create additional geometry to give me the control I need. So for example, projection, right? Following stuff where the surface and the edge that you're following is right on the edge of the model. And so as it's like, hey, if it was just in 3-axis, that would work great. But like we saw with this, right, as soon as we start adding that tilt to it, now the compensation point, the tangency point of the tool, hey, if I didn't have anything here, here's a great example. I'm doing my tilt. I'm going to loft a surface here. Let's do single. Oh, no. Let's do partial. Okay, let's do a second chain. And I'm going to do that guy. Yep. And we're going to do change. We're going to change the surface normal. And just so it sticks out a little bit, let's change the color. Okay, great. Got a surface. I'm going to save it. I'm going to go into the parameters here. That's the chain we're driving. And I'm going to comp to that surface. And we're going to go to the tool axis control, put in no tilt. Okay. So projection straight down. Good to go. And let's do apples to apples. Like I'm showing this with just a surface. What I'm talking about is a solid, right? So I'm going to do solids, extrude. Sure, we're in full chain mode. There's my chain. I'm going to reverse it. Sweet. I got solid geometry. I want to cut around the edge of that thing, and I want to, do it on the face here, and maybe I'm trying to break the edge, whatever I'm trying to do. I want to cut it in a certain way. So let me save this. Let me go into the parameters, and we're going to go to collision control. We're going to do a comp surface. I'm going to grab that face. That's now a solid face. It's not a surface at all. And as long as it's vertical, here we get what we're expecting. Maybe because I am cutting the actual face of the top of the solid part, let's change the cut direction. Okay, so I'm going to go into my curve here. I'm going to right click. I'm going to reverse the direction. Actually automatically flipped the side for me, which is a recent improvement than the last kind of 5 versions of Mastercam. It used to be it would change the direction, but it would still keep the side flipped in correctly. And this really matters much more for an actual contour toolpath than it does for a Mastercam path. So I'll say OK. Still off. Everything's copacetic. But the reason why that can matter is that will control where your exit is. All right. Now what happens? If I go to my tool axis control and I say, hey, give me 35 degrees of side tilt. This is fine, but there's nothing that controls the tool being tangent to any surface like we were before. When we used that flat run-out surface, that was because that was how we were trying to compensate. So to take this a little further, do something like this. I'm going to do wireframe. I'm going to do curve all edges. I'm going to create wireframe on the bottom here. Selection. Yep. I'm going to offset a chain. I'm going to go into solids. I'm going to do an extrude. We'll add this. I'm going to add this as a boss to this target solid, and we'll extend it out by 1 inch. Great. How do I drive a ball end mill around the intersection of this floor and the wall with curve 5-axis so that I am tangent to the wall and tangent to the floor? Well, I know that if we drive a path like, go back in here, let's go back to our cut pattern, select and reselect, there's our new cut pattern. Tool axis control, we're doing a 35-degree tilt. Collision control, I'm going to take out that surface, and let's see if we can give it all of these as compensation surfaces. 0, 0, stock to leave. Did it do us and give us anything that's kind of great and reasonable? Maybe not. One of the things that we can try here, sharp corners are always going to be a pain. So we may be able to do something like this. Let's do fillet. Little 10-thou fillet. Give it something to move around. It's going around these corners. Now that should have kept our chaining association. Yep. So adding a trim will automatically add it to that chain, so we should be good there. And we probably want to increase this to more like 1/10 instead of 1/1000. We've still got a 1/2 inch maximum step. Better. Gave us something to figure out the transition on. Now, if I backplot this and let me actually change and edit, make the tool just a little more opaque. So it's doing something funky there. Now, we can try a couple of things. We can try going into the collision control and just selecting this floor surface. If we do that, we may also have to do some modifications, because you can see with that tilt angle, even though we're tangent on the floor, it's not compensating on the wall. And this is actually, guys, a great example, let me go ahead and save this, of one of the places where these older style tool paths, they just give you problems. Now, I think you could all agree, if we look at this, the need for us to be able to drive a tool that's tilted into a corner as a ball, probably not as likely on this particular example. But the exercise of, well, how do I do it if I wanted to in a 5-axis mode, I think is definitely kind of a good question to entertain. You put in a file, grip V2. Is that something you want to take a look at?
It's a little Independence Day present for everybody.
Sweet.
But yeah, there's some very challenging features.
Okay.
It requires some out-of-the-box approaches.
Okay.
But it's totally meant to be machined on a 5-axis.
Gotcha. Well, we can definitely take a look at this. We'll probably do this in our next session. Download that. Is that something you want to take a look at right now? Is there something you're working on, or?
I feel like this applies directly to it. And like your collision control.
Yeah.
Down inside a mag well, where you need to stay away from walls, where you need to, turn the older stuff on.
Sure. So for stuff like that, I'm happy to look at it. Let's do that. Let's go with that. You're looking to machine on the inside of here with a ball or something. Some tricky geometry in here.
Yeah, see that radius right there?
This guy?
That one's that one I would approach with a slot cutter with the construction plane above where your cursor is. But so if you'll just walk your cursor up about an inch in Y, there's a radius driven around
This guy?
a rectangular boss. No, not necessarily. On the opposite side.
Here. Let's get control. There.
Is this me now? Oh, wow. Yeah, see this?
Yeah.
It's exactly like what you're talking about. Where you're drawing it as a full square, but it's like out in nature, sometimes it happens where you'll have to come at something like that completely different. So like attacking this radius while tilting away from that, or yes, you could drive your tool straight down and over, but if you were trying to be efficient or make 1,000 of these, that's what you're like, this deep dive, that's what I feel like you're trying to push, making quality toolpaths.
Yes. And at the end of the day, it's a Swiss Army knife of all these different tools and all these different options. So which one gives you the best, quickest results, is the easiest to to utilize. There's some, I think, that are in my arsenal that are go-tos. Like, you can't just swarf everything, right? A lot of people say, want to say, I hate to say this, but this is kind of the universal truth. You walk into a shop, they're new to 5-axis. What's the first thing they want you to cut? An impeller for their boss's desk as an ornament. And it's like, well, we can do that. I could show you how to cut an impeller. I've cut quite a few of them. But what's that going to really teach you guys? If I use Blade Expert, what's that going to teach you guys about your day-to-day 5-axis that you need to do your job, right? So, good example. I mean, we would have to look at this. Oh, let me do... What do we do at the transition? Right? We've got some sharp corners that, hey, you may be able to hit that with a wheel cutter, coming straight down. But obviously, this angle is not 90 degrees to this plane. So, sure, you can do this cut with a wheel cutter, but then what are we going to do here? So we're going to have a little fillet, minimal fillet. Is that what you want to call it? Or what do you think? Or do we run that little surface out into this and put a little kind of half moon circle on there? And that's kind of an open question, right? This is some geometry where, if you run a wheel cutter this way, you can hit it, but because it's not straight down vertical with this wall, right? This, if I analyze the angle between these, I bet that's 90 degrees. I mean, we can look, but this is definitely not. You can see that this is tilted away. So here's that kind of that 90 degree look. This thing's got some weird geometry. So sure, you can just take your wheel cutter and have it do this little bump step and let it be what it is, but you still have to Even if you flipped it up like this and took your wheel cutter, it just, the geometry as designed makes it pretty awkward. So you're going to really have to figure out what you want to do. Now, as far as approach goes, if we're on some 5-axis machine, and let's just assume we're holding it, I don't know, by this end or something, so that we can freely rotate this thing around and get access to it. And let's also assume that that's how it's set up. And let's do this. Let's move it around a little bit. Put it into a good position. Let's get this saved. So I want to line this thing up as if this base was kind of flat to the world. So I'm going to select it. I'm going to go into the dynamic manipulation. I have it set so that it does not automatically switch to geometry, which is my preference. So I'm going to click to place the gnomon. I'm going to grab the XY flat plane, and I'm going to align it with the XY flat plane of the bottom of the part. Now I'm still in manipulate gnomon. The Z-axis is kind of pointing the opposite way. So I am going to rotate it around 80. And I really want kind of the center of this opening to be in the center of my part. So again, I'm going to place the gnomon. I'm going to grab the little origin point. So this is just going to change position. It's not going to change orientation. So, okay, so I get an arc there. So I hit M to go to midpoint, and it looks like this edge on the solid is not, it's like a spline. You can actually see that. You see how there's no lines across here? So this is a great example of where the geometry itself has got some weirdness to it. So before I even move it, I'm going to back out of that command. Let's make sure we clear the colors. I'm going to go into model prep. I'm going to go to optimize. So this automatically repairs imported solids. Bodies are individual faces by improving the accuracy of the edges and blends, etc., etc. So I'm going to do optimize. Now it says, what do you want to do? I'm going to select the entire body. I was really thinking about this one. 479 changes. Sweet. Now, I'm going to do it again. Looking to see every time I do this is kind of a reduction in how many fixes get made until the point where I'm no longer seeing any actual progress. And what I mean by that is you'll eventually get to a point where it says it's doing the same number of things kind of every time. So last time was 124, now it's 122, or maybe it was 142, but it's getting pretty close. So that's probably good. You can also look and see if there are any areas on the model which may need to be simplified. Here we've got two different blends. Now,
the entire trigger guard.
What's that?
The entire trigger guard, in my opinion.
All of this?
Yeah.
Yeah, okay, here's a good example, right? If this is the same radius, for example, we can go in here and do simplify solid. I'm going to have it selected for edge. I'm going to try to just simplify these edges. So I'll select them, say OK. Oh, no potential simplifications were found. So if I try to give it individual inputs, it's not working. You can always try it on the whole solid. So I'll select the whole model. Was able to do 10 simplifications. So it found some geometry area here. This is cool because now what this means here is that we should be getting rid of that break in the face. Tells me redundant edges, faces removed. Okay, so we did that once. Now that some of it's cleaned up, often if you run these tools kind of sequentially, it can keep finding additional things. So we'll run it again. No potential simplifications were found. I'm going to save the model. And because we did some simplify, we're going to try optimize one more time on the whole thing. Because maybe that simplification was able to help us clean up some things. So still showing us, not simplify, let me do optimize one more time. So we had 122, we had 126 when we just ran it again, and it's back to 122. This tells me in the process that it's not able to clean it up any further than that. Some other tools that we've got to analyze it before we just jump into the toolpath, because I think this is also good to know. We have analyzed distance. We have analyzed distance along curve. Analyze dynamic. For those of you guys who haven't used this a lot, this is a really handy tool. As a machinist, what's the first thing that I'm doing when I look at this part? There's a hint. I'm not looking immediately to figure out what toolpath am I throwing down. I'm looking at what tools do I need to order or dig out of the tool crib, or et cetera, right? But look at this. This is interesting. So here, you've got some weirdness where there's an intersection here.
It's not a tumor.
It's not a tumor at all. Yeah. So there's something interesting there. I would probably solve it by doing something like this, because keep in mind, we can just do a regular solid operation on here as well. First, I'm going to figure out how big is this hole. So this is a great example where analyze dynamic. Analyze dynamic is click on something to analyze it, click again to stop analyze it, and then go and click on something else to be able to analyze the next thing. So here I'm looking, this is a 5/16 diameter. This one's also a 5/16 diameter. If I go all the way across, 289. Okay. So there is a step here. That's great. So that would tell me that this is the 5/16 end. Again, I'll click on dynamic. We want to analyze that. Great. It's 5/16, 0.3125. So I'm going to do wireframe, create curve on one edge, create that curve there. Perfect. Solids, extrude. I'm going to click that circle. I'll look and make sure it's going the correct direction. It is. So I'm going to tell it, cut a body, extend through all. Now I am getting a warning. What's the warning? Boolean remove operation failed. Parasolid kernel interface error. Boolean operation failed. Failure generating Boolean operation. So, it's not liking that one. Now, let's analyze this arc. It's on view number 5, so it's actually on one of the right side planes. The angles are kind of funky, so I'm going to make it sure it's set to 0 and set to 360. And then I'm going to cheat a little bit. How am I going to cheat? Let's go 315. Actually, it was 3125. Let's make it 10 thou bigger. 3225. Okay. Now I can try extruding this again. So we'll do solids, extrude that guy, cut body. Making it slightly bigger is working, but I want to make sure I go through all. So I cleaned up that weird feature, and you're like, yeah, but Colin, you messed it all up, right? Maybe, but here's what we're going to do. We're going to say, okay, I'm going to analyze that arc. So we made it 10 thou bigger. I'm going to make it only 5 thou bigger. So I'm going to decrease that by doing math right in the dialog box. I'm going to subtract 5 thousandths, and we're going to go to the solids, and we're going to try regenerating. Okay, so making it 5 thou was bigger, was able to fix it. I want to make sure that I'm not intersecting that. That looks good. And you say to me, but hey, that's all well and good, but the feature on the solid doesn't really match what I'm doing. I know. I need to make the radius 2.5 thou smaller because I'm 5 thou bigger on the diameter. I need to adjust this by 2.5 thou. So I'm going to save this. I'm going to go to model prep, and I'm going to go to push pull. I want to be careful of the order in which I select the faces, but I can get them both at once. So I'm going to go to that face. Oh, and I have to remove history first before I do this. So, okay, we're going to remove history. And I'm going to grab that face because they're both the same diameter. And now it tells me radius 1.5875. So I'm going to click on that radius, and I'm going to start typing. So I'm going to type decimal point. 15875 minus 0.0025, which is the radius. I'm going to hit enter to accept the value, and I'm going to hit enter again to accept the change. And I'm going to say OK. So I created a bigger arc to be able to extrude and cut away the geometry. We removed the history on the model, and then I used push and pull to bring these two features radially back to the correct size. How do I know they're the correct size? Well, I'm going to go back to home. I'm going to go to analyze dynamic. 0.3125, baby. Okay, so there's a lot of work that we can do with the solid tools. This is a great example, but you wanted to look at the particular 5-axis path for doing this. Sure. So let's get back to toolpaths. We were going to move this thing around, and this is funky.
It is funky.
Yeah, that's a funky path. So let's do this. I'm going to go, before we even worry about modifying it, I'm going to go to, let's move it. So transform, dynamic, we're going to move that part. We're going to set the X and Y. Okay. And we're now going to tell it that we want to move geometry. So I'm going to press the little move geometry button. And I'm going to say that I want it to align with the world WCS. And let's also move it to the world origin. We're going to copy that. So what I'm going to do, I'm going to move this to a new level and name it MFG solid. And I'm going to move this thing to some other level. Okay. So now in our levels, here we go. Part of the reason I wanted to move it to be in the top orientation, I can go into my dynamic and I can select that face and I get the angle from vertical. So it looks like it's a 15-degree chamfer, but it looks like it goes from 12 degrees here to 15.7. Why they need a progressive on there is weird. Over here, it's more like 33.8.
It's for John Wick stuff.
I guess. So yeah, they've got some weird geometry to transition there. Now, can we cut it? Sure. But if I want to use it for orientation, that's going to be a tougher story. Now, I do have edges that aren't transitioning or moving from one angle to another down here. The whole point of this is I was like, hey, how do I take the middle of that mag well and stick it at the center of my origin? So, okay, I'm going to do a dynamic again, and I need to orient my gnomon. So I'm going to flip it over 180 degrees. I'm going to take the origin ball, and I'm going to find the midpoint there, and I'm going to hover until it creates the little temporary midpoint, or temporary point on whatever feature you're on. And I do those two that are opposite so that I can get my temporary midpoint. And now I say, great, that's what I want. And I want to move this. I want to reorient it and move it. And I also want to move the origin. So, okay, great. I can also do one more dynamic. Let's put it on the end here. Let's set it to move geometry. And I'm going to click on the spindle so that I can move it up and down. And as I come down there and find the origin, it'll actually find what the offset is along that axis to put that feature at the 0 position. So if I zoom in my eyeballs, 0.29522, great. And we'll say okay. And so now if I look at this from the front view, if I look at it from the right side view, I am centered, at least on the bottom portion of the magwell. I realize the magwell is tilted, but what I'm looking for is a face that I can anchor on something to do some additional work. Check. All right. So the part is in position. I'm going to save that. And now, depending on how we want to cut that little radius, I would be using a ball end mill. And rather than trying to drive it right off the surfaces, right off the solid, I would create some surfaces. So I'm going to come in here and do surfaces from solid. Select these. I would probably also grab everything that's around there and say end selection and OK. And that allows me to turn off that solid and just be working with this geometry here. Now, if we analyze it, like 2 radius. Let's make sure it's the same over here, 0.2, okay. And even, zoom a little bit, flowing around this little guy, it's constant, 0.2. Okay, so probably use, the bigger end mill we use, right, the farther we're going to have to stay away from where these sharp edges are. And, it's kind of, you have to, I guess, decide, are we going to put a little fillet in here and just use a little tiny ball end mill to do it? If we were, what would that look like? What would a reasonable size for this be? 30 thou, 40 thou, 1 millimeter. If I go to surfaces and I do a fillet to surfaces, so a surface to surface fillet just to check it, I'm going to select this as the first set of surfaces and press enter. This as the second set and press enter. I'm going to go in here and do a radius of, let's do 0.02. Okay. So that gives me an idea, right? Like how much clearance do I really need on here? That's with a 1 millimeter tool. If I change this to 10 thou, it's not as bad. Okay, so I'm just getting an idea of, what kind of tool is going to fit in there. Let's do it with some small tool. So tool paths, and this is where curve 5-axis is not the tool that I would pick out of my toolbox for doing this. I would definitely switch over to unified. Probably before we get into that, yeah, I know drive surfaces are missing. Do you want to keep the operation? Yes. Before I do that, what I'm going to do is come in here to wireframe, curve on one edge. Now we're going to have a problem here, transitioning from a radius to no radius. So even though this is sharp in the geometry, I'd say nope. Let's get at least a small rad there. Is 20 too much? Maybe. Let's see what 10 looks like. Yeah, we could probably live with 10 thou. So we say OK. And now we have at least something to work with. So tool paths, we've got our unified. Oh, and by the way, guys, yeah, I did see a message from Tim offering early dismissal today. So if you guys want to take off and get out of here, feel free. Probably going to go for just a few more minutes, probably till 4 p.m. my time, about 20 more minutes. But we're recording all this, so if you guys just want to take off, got stuff to do, I totally understand. We went over our scheduled time anyway. So feel free either way to hang out and stay for another 20 minutes or to bail and watch the video later. So Thanks, guys. Anyway, I'm going to go in here and create a tool. Let's do a ball and end mill. And we're going to do like 1/32. Pretty small tool. Definitely not going to be 4 inches long. This ends up being 6,000. Maybe this is 1.5 inches, something like that. Shoulder. Okay. Little ball end mill and under the cut pattern. So the path that we've talked about so far has been curve. It's a lot simpler. There's a lot less to it. There is a lot more to unified. So we'll just do a very brief introduction here to play around with it. There's automatic, there's curve rows, there's surface rows. I would look to do this either with automatic or with the curve row. So we can do curve, and on the option, we have guide, we have project, we have morph, perpendicular, parallel. In this case, I'm going to choose morph. So when I switch to morph, you'll notice it changes to 2 curves. So we have the selection for the first curve, the selection for the second curve. This is important because this selection button is selecting the entity that is highlighted in the list. So first curve, I'm going to select that chain. Also, when we do this, one thing that's important to note, I'm going to go back in there and do this again. So morph, it's going to go to the 2 chains. When I go into my chaining mode, in the options, there is a function for chaining called sync. And if the default is none, what that means is that as you step along the 2 chains, that we're basically just stepping with the same step increment along the chain and then kind of tying between the 2. And what's going to happen is when you come out here, if I step 1 thou and 1 thou, I am quickly going to run out of entity here because this entity is much shorter. And so you're going to end up with this weird motion where it's not perfectly kind of connected between the chains. It's doing this weird like tilting. And so in this case, we want to make sure sync mode is turned on, and sync by entity is typically the one we want to use. So you need to have the same number of entities in each chain, and you may need to modify the chain to suit. So I wanted to be sure that was turned on to sync by entity. I'm going to grab that chain, and that is my first chain. You notice it says 1 entity, even though it's a chain made up of 3 different pieces, 2 lines and an arc. It just says 1 curve. So we're going to go to the second curve and select it. We want to make sure they're both kind of driving in the same direction. So that's good. Maximum step over, I'm just going to set it to 10 thou. Geometry, what are we machining? So in this case, I can actually give it all of this geometry because it should be transitioning only between the 2 chains, and we want to keep all the rest of that stuff tangent. I'm going to leave it set to zigzag standard, and I'm not going to touch anything else. And I'm doing that just to see what it gives me by default. Yeah, so I was trying to consider too much, so I'm going to go back in the parameters. This is where we get to get a little tricky with it. So machining geometries, let's remove that. We'll let it generate, see what we're getting here. believe it or not super bad. We're doing a little tilting because it's trying to use the normal of these surfaces, but the motion itself, not so bad yet. Let's not even worry about the tilt axis yet. We're going to get there. All right, so we know that conceptually the path is flowing along the geometry the way that we want to. Now we got to figure out what's the best angle. Just close that out. What's the best angle? So I'm going to go back into my levels here, turn on my solid, and say visually, it's the way that we want to look at this. Sec here, guys. Right, no, okay. So if I look at this in the top view, if I look at this in the right side view, if I look at this in the front view, we've got these kind of different standard planes that we've got aligned. So there's multiple ways that we could go about creating the plane or vector that we may want to use to do this machining. So I'll show you a couple of them just real quick. Let's just pick one. So let's say, for example, hey, I really like that angle. So if I have a line that is projected out from there, what might that look like? I am going to go into planes, and I am going to go and say from graphics view. So exactly how I'm looking at the part, I want to create a plane. And this is going to be, temp, whatever. And I'll say okay. And I'm going to right click. I'm going to set this to 2D, and I'm going to set my Z depth, say off this corner point right here. And now I'm going to go into transform. And, wireframe, create point by position. So I'm just going to create the point right here. I'll just create it at the center of the arc. Now I'm going to go into transform, project. And it says select the entities to project. I'm going to set my quick mask to only points. I'm going to grab that point. And I'm going to move it, and I am going to project onto a surface or solid. So I'll select that guy right there, hit end selection, and now because I'm doing a surface projection, I can project, I don't want normal, I want it projected in the view, and I want to project the line, and I'll say okay. Oh, I did it normal to the surface, so I got to delete that guy. Sorry, guys. Delete that. Wireframe point. I'll take that point, and I want to project it. I want to do it. I don't even need to project. I'm already in the view. I can just transform it. Translate. I do need it.
Click plane.
Because if I don't do the surface projection, I can't do my project lines. Oh, you know what? I'm just going to translate the point. I'm going to translate the point and join it. So join in Z 1 inch. There we go. That's the view that I created. That's the line. Now, I did it on a temp plane because I don't necessarily on my G code want that line to be some weird angle. I could just live with it, whatever it is, that's going to be fine. But I'm going to go back in the top view here. Let's look at this in the top view. And now that I'm in the top view, I can analyze that line, analyze entity. I've got my start point, which is the good anchor. And I'm like, okay, 325 is fine, but 0.68032, no, I'm going to make that 0. So we'll say okay. And now if I change to the front plane, look at this in the front plane, and I analyze this again, 15.72, whatever. I'm going to either make it 15 or 16. So is this necessary? No, not necessarily. But if I want this thing to be, a good option, I should take my time to create the right geometry. So I could use this temp plane as the tool axis control. I can also use the line or the vector for the tool axis control. So let's go back into this unified path. Ooh, before I go too far, save this and be smart. Axis control. Right now it is coming off of the surface with tilt. So what I'm going to do is say lines. Now, one of the things that's not shown in here, which is really going to mess you up if you're used to the curved 5-axis, you actually want it pointing towards the geometry from the tool, not from the geometry back towards the tool. It's like it's opposite. So just a word to the wise. Let's say okay. Let's let it generate. And let me turn off the manufacturing solid. Oh, didn't even generate a path. Wow. Well, let's see what happens if it's opposite. Maybe they changed it around on me. Let's go like this. Let's go reverse it. That's better. So it is reversed. Okay. So now, because we're setting our approach, now obviously we'd need to put it inside the right holder. We'd need to determine, is that enough? Do we want to tilt more? But we can adjust that, right? Because now, if I want to go and modify the path without changing my planes, I've got a vector line. So in my planes, I'm going to still go to the front. I'm going to analyze this. We did 15. Let's do 35. Let's see what that looks like. Because the path is tied to the line instead of to a plane, I've now got control to be able to, kind of adjust the angle that I'm using for this particular cut on the fly. So back plot it. You say, Colin, that looks good, but, right? Boom, boom. Okay. all is not lost here. This is exactly where these different controls come in on the toolpath. So I'm going to go back into the unified morph. We're going to go to collision control. And right now, this is set to trim and relink toolpath on the collision only for the machining geometries. So if the machining geometry has some collision with the tip of the tool, it's going to remove those collisions. We're going to add some more. So I'm going to add a control here that's not on the holder, shank, or shoulder. I'm going to add it to the flute. And instead of tilting tool, I am going to retract the tool. I am not going to use the machining geometry. I'm going to use some avoidance geometry. And look at these tool retraction options. All of these different options, away from origin, a long cut to center, blah, 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 blah. I'm going to retract along the surface normal of my avoidance geometry. And what's my avoidance geometry? A surface or a solid face, don't care which. And give me a tolerance, give me some stock to leave if I want it. If I want to stay off of there by, 2/10, I can do that. One change at a time is my recommendation. Just as a general word of warning, you may have to increase the size of this surface so that it has the correct geometry to pull away from. Now, do we want to let it jump up and over there? We could. We can also say trim and relink, trim collision only from the avoidance geometry. If we do that, we want to make sure what I'm getting at is we want to make sure that we have enough points that are being output. I think a 1 thou tolerance should be okay. So if I just tell it to trim and relink, instead of retracting away from that normal axis, because we are tilted, so that's the other thing we have to consider. So tool comes along there. It comes up to, but does not violate the surface. And what do you think we got to do over here? Same thing. Now, can we combine them in one? Maybe. So depending on which piece of the collision control with the avoidance geometries and the settings, we could. If you need more, there are actually 4 total collision control strategies built in. Adding a collision control strategy increases the time. Now, I don't think this first collision control strategy, trim and relink toolpath on collision only for the flute and the machining geometries, is that effective. I'm actually going to do retract tool along the tool axis. So whatever orientation our tool is facing, it's going to retract. This is tangency control. This is collision compensation. So machine geometry, retract the tool, make sure we're tangent, good to go. We've got some avoidance geometries there. And I'm going to add another one over here. Well, I tried to hit 4 p.m. We're just over. And let's see if that gave us a good result. Now, we can clean some things up. We're doing these little blend splines as our connection between the slices, and that is under linking. These paths are super powerful. There's a ton of stuff we can do in here. So we've got this set to blend spline right now. I'm going to do follow surfaces instead. And this, tell me how I did, Ron.
Close.
So with relatively little inputs, this thing just has some amazing controls to be able to say, okay, what do I want to drive? What's the pattern of the cut look like? What kind of geometry are we driving? How are we orienting the tool? And only then, how are we keeping it from gouging into the areas we're concerned about? And a lot of the times, I'm going in here to get the cut pattern right. I can bump up my numbers, right? So I can go into my cut pattern and say, yeah, I'm at 10 thou. Let's do this with like a 30 thou step over. Why? Because I want it to calculate quick. Time is money, right? Is the motion of my tool that I'm driving even remotely correct? Because if not, I may have some other things to change. I may want to do one way instead of zigzag, whatever that is. And I can look at this and say, cool, it's only making 2 passes, 3 passes, whatever, but the directions look right. And so, okay, I create my cut pattern, I get the tool axis right. And the nice thing about tying this back to geometry, instead of tying it to an angle from axis, there's a whole bunch of things that we could do. I'll show you guys fixed angle to axis. That one's pretty sweet. It just allows you from the WCS to dial in the angle of the vector of the tool path without having to create any geometry at all. But as we get into these more advanced tool paths, there's like 10,000 different parameters. So it can get overwhelming. Don't get me wrong. I've been overwhelmed myself. So don't want you guys to worry about, oh man, there's a lot. He's covering so much. We're going to go through all this stuff till we all have a great understanding of it. And thank you, Ron, for providing such a great example to use during class of, hey, here's some difficult geometry. It's great. You're showing me a contour on a flat piece of surface and yada, yada. But here I'm trying to create this, really complex piece. And could I have done this without creating the extra surfaces? Yeah, I could have driven this right off the solid. Could I have used the solid edges? No. And I say no because to get it to really flow and act appropriately, it is a good idea for us to have at least a small fillet so that we have 2 chains that are kind of synced in the total number of entities. Otherwise, we may run into some problems. Could you modify the solid to include that? Yeah, you probably could. But again, sometimes I just want to work on a specific area. I don't want, the rest of the part. Let me go back to my levels. I don't want the rest of the part getting in the way as I'm, working on it. So I'm going to hide everything else by just creating some surfaces on a separate level and then being able to drive those surfaces. So just real quick again, toolpaths, back plot. And I would obviously, if I was doing this for real, right, I'd put it in an ER16 or an ER11 or shrink fit. So I would go in and I would do the whole holder thing. So maybe we are, Yeah, let's use a nice side lock end holder. Some better stuff down here near the bottom. But we'll pick this one. But you guys get the idea, right? And maybe we're going to stick this thing out 3/4 of an inch. Okay. And now we can kind of evaluate what's our approach look like. You know, a miss is a mile, right, guys? Now, we could tilt this, we could do all kinds of things, but great little example run of an area where, hey, driving this with kind of traditional tool paths is not working so great. And maybe you need to do something over here to clean it up because you're going to use a little wheel cutter and that's going to leave a little chunk of material in there. And in some of those cases, I'd create a tool path to do kind of the whole surface, but then I would use stock. Because with stock, we can really tell it, hey, I only want to cut in this area. So just as I know we want to wrap up and everybody wants to get off for the holiday weekend, and I want to respect that. But just real quick while we're here, to take these surfaces, I'm going to copy them because I think this is an important trick and I don't want to forget it. So, let's go copy 215. Okay. Something that is new, by the way, I've got these 3 surfaces. I'm going to select those surfaces. I should have copied them originally. I moved them. That was my mistake. I want to figure out, hey, can I just manipulate these, or are these my surfaces that are tied to my toolpath? If I do analyze entity, they've got this kind of new option here for association. So you can actually see which toolpath that surface is tied to. Modify the current entity or select others to edit. So say okay. If I select that guy, okay, so these are all tied to toolpath number 1. Okay, no problem. So let me turn that off. These are the ones I want to modify. So what I'm going to do here, these blue or some other color. And if I analyze these ones should not be tied to the toolpath. They're not. There's no association there. So I'm going to create wireframe, create a curve on one edge. Ooh, and let's make sure we're in 3D. Excellent. Say I only had a bunch of, I only had a little stuff to do down here. So I'm going to do modify length, shorten 100 thou. This is good. This will be a good example. Okay, so I'll shorten those guys by 100 thou. And I'm going to create create a curve here. I'm going to create a constant parameter curve. So I'm going to click on there. I'm going to find the endpoint, and it's going to give me one direction. I actually want the V direction, so I'll select that and do OK. And I'm going to do the same thing over here. Select that. That's going the right way. I'll say OK. In surfaces, I am going to do a trim to curves. I'm going to trim this surface, and I'm going to trim it to a single entity. I'm going to trim it to that curve right there. OK. Indicate an area to keep. Before I do that, I'm going to tell it, oh, I have to do this first. Okay, so click on it, indicate the portion to keep after trimming. I want to keep that side. I also want to turn on extend curves to edge just in case it needs it, and make sure the project curves is set to normal. I'm going to do apply. I'm going to double click that surface. I'm going to select single. That's the curve that I want. I'm going to indicate the area I want to keep. Okay, so this is a fun little trick. I'm going to get rid of all my wireframe. I'm going to select all wireframe. We're going to delete it. Oh, let's undo that. Save this. That may be a trimmed surface, so it won't let me delete the wireframe. That's fine. So what I'm going to do, I'm going to do toolpath, mill toolpaths, stock model. I'm going to set this to initial stock shape to model geometry. To grab those 3 trimmed surfaces, and I'm going to say additional offset. Let's go 20,000. It's maybe a little much. Let's do 10. What am I generating? I'm generating a piece of stock. And it is kind of separated. Let me go back into view here and turn off my levels. That piece of stock is separate from the surfaces that I'm driving. So I still have the surfaces that are being driven, but if I look at the toolpath goes all the way to the edge of the surfaces. If my stock was only here, I can create some simple surfaces, give them an offset to define the stock that I actually want to cut, and then inside my toolpath, stock, use stock. I am going to use a stock model, or I can select the geometry and just do it right in the toolpath itself, or use another solid if that was where my stock was. And don't want to check the shank or the holder because I don't have to worry about any of that. Generate. So the toolpath by default is always trying to cut all your geometry that you fed into the algorithm, unless you're specifically telling it where the stock is. So if you tell it where the stock is with a stock model, you don't have to worry about any of these collision control things, right? Like I could say, all right, there's my stock, there's where I want to cut. I've got in my collision control, I've got this guy. This takes time. This takes processing time. So I'm going to get rid of that collision, and the result's going to still be exactly the same because I told it where the geometry or where the material to be removed is. So like I said, if you were running this and this has got a little overhang, so maybe when you run your wheel cutter, there's like this triangular chunk of material left over. So in a case like that, if we unshade this, you can see, there's the chain. Yeah, we may have to define it a little differently, but we could easily just chop up one of these surfaces to fit where that piece of stock was that we saw, right? If we were running a wheel cutter along here, maybe there's a chunk of stock there, we could define it, and then we just throw a toolpath on it, and that toolpath kind of exactly matches up with where the geometry is that we've defined as our stock. So pretty sweet little tip there. Hope you guys get to take advantage of it. All right. Happy 4th of July, my friends.
Colin.
All right. Thanks, Colin.
You guys are welcome.
Thank you, Colin.
Yep.
Thank you. That was awesome. Thanks.
Awesome. All right. I'm going to go ahead and shut